midterm exam. Pick the vocabulary word that best describes DE. DE is this middle line up here, and they connect the midpoints. So that would be called a midsegment. Midsegment connects midpoints, all right? Obviously not an angle bisector or perpendicular bisector or an altitude. Altitude comes from the vertices. Angle bisectors comes from the vertices, and the medians come from vertices, all right? So number 2, if AP is 10, then what is AB? All right, so if AP is 10, then that means PB is 10, and all the way to AB is 20. Many of you just put 10 there. A to B, the whole segment, okay? All right, number 3, find the perpendicular slope. All right, lots of people keep screwing this up. Listen, you have got to remember that you have to take the change of the y coordinates on top. Everybody remembers rise over run. Okay, but for some reason you put the subtraction of your x's on the top. You know, x-axis is left and right. You run this way. You don't run up and down, okay? So think of rise over run, and you'll never forget which one goes on top. Okay, the change of how much you're going up and down, that's the y-axis. Okay, and that's the biggest mistake everybody made, most people made, or that missed this problem, and a lot of you missed it. So what you're doing is you have to take y minus y. It doesn't matter which way you go as long as you go the same direction. I'm going to go left to right, so -2 minus 5 on top, and then left to right for the x's. 9 minus a -1. So -2 minus 5 is -7, and 9 minus a -1. Change, that's 10. Perpendicular is what we want. So you got to turn it over and change the sign. So it's positive 10/7. That's what you should have put. Lots of crazy answers on this one. Okay, number 4, DE is a mid-segment. All right, and we're looking at this right over here. If AD is 4. So first of all, DE is a midsegment, which means D is a midpoint and E is a midpoint. So AD is the same as DB, which is the first question. DB is 4. And then it says DE is 9. What's BC? Well, that's double that. That's 18. All right. If you're not sure of what that was, it comes just from the same thing as the trapezoid midsegment theorem. You take the top, which there's no top, okay? So on a typical trapezoid, this would be your top, except you have this triangle here. There is no top. You have 18 here, and your midsegment's 9. So the top is 0, the bottom is 18, divide by 2, that gives you 9. The midsegment's 9, except we didn't know the bottom, so that would have been x, and you would have solved it from there. Okay? Either way, the answer is 18. Number 5, plot the points and connect them, make a triangle, draw 3 perpendicular bisectors in order to find the circumcenter. So there was definitely at least 40% of students drew angle bisectors. Okay, that's a problem if you don't know the difference between an angle bisector and a perpendicular bisector. Okay, so 1, 2 is right here. That's J. 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. And up 6. 1, 2, 3, 4, 5, 6. That's K. And L is at 9, 2. So it's a right triangle. And you want perpendicular bisectors. Okay, so let's do JL. Bisecting JL. That's what you got to do. So it is 8 units long, so we're going to count 4. 1, 2, 3, 4. So right here is the bisector and we make it perpendicular. Okay? And then we do the same thing for KL. It's 4 units long, so we count up to 1, 2, and draw a perpendicular line bisecting that segment. And where do they meet? Right there. What coordinate is that? 1, 2, 3, 4, 5. 1, 2, 3, 4. 5, 4 is where the perpendicular bisectors meet. That's called the circumcenter. All right. All right, state if the numbers can be the lengths of the sides of a triangle. Okay, show work to justify why you say yes or no. Okay, so you're supposed to add the two smallest numbers. 5 plus 12 is supposed to be bigger than the third side, 19. Well, 17 is not bigger than 19. So we cross that out and we say, no, that's not a triangle. The two smaller sides have to be bigger than the third side. All right, number 7, what are the two possible lengths of the third side? So to get the smallest side, we subtract. 25 minus 10 is 15. To get the largest side, we add them. 10 plus 25 is 35. Put x in between, and then you put less than signs. So the third side can be anything between those two numbers. Hopefully you now remember that. Which side is shortest in this triangle down here? So we have, you're looking at the angles here. So 46 degrees, is that what that is? Let me just blow this up. Okay, so we have 46 degrees. That's the smallest angle, so therefore it is across from the smallest side. All right, so the shortest side is what they were looking for, and side length, so you say LK. The segment LK is the smallest or the shortest length. Okay, now we go over to which angle is largest. So now we're asking for an angle. Again, people, angles are either 1 letter or 3. And you're always best to just give 3 letters, but in this case you only need 1. So the largest angle is across from the largest side. The largest side is 22. It is made by angle M. All right, let's go to number 10. Same type of thing, RT and VX. So RT is this angle or segment right there, and VX is this segment. They are across from the angles. These angles make up that side. So 100 is bigger. It's across from RT. So RT is bigger than VX. All right, number 11. The sum of the measures of the interior angles of a 14-sided figure. So you take 14 minus 2 times 180. So 12 times 180. Oops, 12 times 180. 2160. I had so many different answers there. 2500. I guess 14 times 180 gives me the 2520. You have to subtract 2. That's the theorem, okay? All right, so that is the second page. Let's go to the third page here. So solve for x. All right, first of all, how many degrees are in there? We have 1, 2, 3, 4, 5, 6 angles, so that means we have 6 sides. So 6 minus 2 times 180. 4 times 180 is 720. So all of those add together, x plus 140, plus 130, plus 120, plus 90, plus 150. Add all those up, 140 plus 130, plus 120, plus 90, plus 150 is 630. So 720 equals x plus 630. So we subtract 630, and you get 90 equals x. That should have been your answer. All right, AD, we need AD. AD is the same length as BC, so 11.7. And and then angle ACB. ACB. So ACB. So this angle right here is what we want. Call X. The whole length is 65. These are parallel lines. AD and BC are parallel, cut by that transversal. Alternate interior angles. So ABC is 30 degrees. You guys use alternate interior angles and corresponding angles in every math class. Not regularly, but a lot of story problems and stuff. Makes your life easier if you remember what they're asking. All right, so that was 30 degrees. Now, 15, state the best name, okay? All you have is opposite sides being congruent. That's all you have. That's marked, okay? So if you have opposite sides, both pairs of opposite sides, then you can say you have a parallelogram. What that means is that's the converse. The converse is that you have opposite sides. Using that converse theorem, you then can say you have parallel sides. But you can't say they're parallel until you've proven it's a parallelogram. So I have a lot of students telling me that they're parallel and congruent. You can't say that until you say it's a parallelogram. Okay, so the only answer you could have given there is parallelogram opposite sides converse theorem. All right. Now, what's important on number 16 is that you understand what a rhombus is. The definition of a rhombus is all four sides are congruent. These are angle bisectors. And that the perpendicular, the diagonals are perpendicular to each other and they're bisectors of each other in a rhombus. So lots of stuff in this picture. So EF is 20. EZ is 6. Let me erase some of this. EZ is 6. And ZHE is 30 degrees. So this angle right here is 30 degrees. It wants ZHG. So ZHG. That's what we're looking for. This angle right here. Well, I just told you the diagonals of a rhombus are angle bisectors. So that's 30 degrees. Any questions on that page? All right. All right, the flag of Scotland is a rectangle with white stripes as the diagonals. Okay? In rectangle SCOT, SO. So the whole, the whole length there is 72, which means each one of those is 46. 46, where am I getting that? That was a different test, sorry. 72 would be 36. Each of those are 36 in length. CO is 45. And CTS, this angle right here, is 32 degrees. All right, so what is CL? CL, they're asking for the whole length of that diagonal. Well, it's the whole length of SO, which is 72. Believe it or not, many people miss this. 72. That's the length, not degrees. All right. Number 16, it's a square. You should know a whole lot about the square. The same thing for a rhombus is true about a square, except a rhombus doesn't always have 90 degrees. So knowing that it's a square, we should be able to get BAC. So BAC. So in a square, this is 90 degrees. And also in a square, your diagonals are angle bisectors. So these two are the same. So we're looking for BAC, which is this angle, which is 45 degrees. 45 and 45 make the 90. Okay, so 45 degrees. And now we go to the best name. All right, yes, it's a quadrilateral. Listen to me. you can't call a parallelogram until you prove it's a parallelogram. The only way you can say something's a parallelogram is if you have the parallel markings. That's why it's important to note the differences between when you're saying a converse theorem or not. Look, when you're done, and I didn't record any of that. The last few problems. Anyway, those are the answers. Any questions? All right.